Hi everyone. Want to share a demonstration of my final game for Southern New Hampshire Gaming Class 303. For this course, we were supposed to design a prototype of three different game options. I picked a fuzzy game where you have to capture wild fuzzies and you get points for it. So the landscape is just the default and Unreal Engine 5.3 new empty project landscape. I made these fences here, which are just some static meshes. They are one fence post, two horizontal pieces. I turned them into a blueprint and then stuck them around the play area. This box that you see, if I can select it, not that one. Okay, the one that's selected now, that is the spawn area for the fuzzy creatures. I made some static mesh trees, placed them around, and then I made a rock and then turned it into a foliage just to test out the foliage capabilities as obstacles for the fuzzies and the player to go around. Without further ado, we'll go ahead and hit play before we look at how the program's put together. So when it starts, the fuzzies are created. They're placed within the bounding box and level there. You have a objective of capture. It's randomly set to capture blue, red, or green fuzzies. And once you capture all the fuzzies, or the timer runs out, the game will finish. When you run up to the fuzzies, you get a little interact when you get within a actor that has an interact interface attached to it. Run, catch them all. Okay, one more or two more fuzzies. Catch that one, last one, just so we can see what it looks like at the end. Fuzzies are running around on a behavior tree AI. Okay, that should say play again or quit. We'll go ahead and hit quit. And let's go ahead and look at some of the content we have here. So I made a blueprint interface that actually has one output of target fuzzy, and that lets you be able to, which is an enum. We'll look at that enum in a minute. That lets you determine if the fuzzy objective is red, blue, or green, as it said at the text at the top of the page there. And if you try and pick up the wrong fuzzy, it won't let you pick it up. So that's what that is there. Let's see. Let's go ahead and dock that for now. Okay, blueprints. Okay, we have a HUD, which then has the game over widget blueprint, as well as the timer, counter, and objectives. The code for each one. So here's the countdown for the timer. Built-in event tick, and wanted to have it down to the second, so I put a delay in there. That helps slow it down. That way, if somebody's system runs faster than somebody else's system, it's still limited to a delay of 0.01 seconds per update of the countdown event, which this calls this event up here. That helps set it down, and so if somebody's FPS is twice as fast, their game won't run twice as fast on the timer. Okay, for getting the objective, that's in here for objective and fuzzies caught. For getting the objective, just cast the player, get the objective from the player character. This is something that needs to be refactored and put into the game mode actually, but right now it's in the player character. Appends it to the string and then returns it to the output. And then finally we got the fuzzy count, which also grabs it from the character. That also needs to be moved into game mode as a refactor and then returns the node. Looking at some of the blueprints, all right, we'll look at our fuzzy first. So you have your fuzzy, and what it is we attach the interact widget to the player from the fuzzy pawn, and then we pick up the fuzzy using that interact capability. We add the widget to the viewport and remove the interact from the viewport when they are outside of range. Construction script, we go ahead and cut through. We go to the static mesh. We set a dynamic material instance using the color of the material instance. Um, then we also grab the other components of it. We go ahead and set it as a variable for dynamic material instance for fuzzy color, and then we set that material for all the parts. We set a random fuzzy type every time a fuzzy is created, and then it'll set the color, and then based upon the three options that are in the enum, it's going to set one of the three colors. So every time you look at a fuzzy, it's going to change color. All right, let's look at the fuzzy spawn. So the fuzzy spawn is just a box, a spawn volume or collision volume that is set up around the area here. And in the event here, what it is coming all the way to the left here. Okay, on begin play, set a slight delay to give everything to finish initializing. We're going to set a random number of fuzzies to spawn, in this case 15 and 25. You could also set up static numbers or player defined values of I want 5 red, 5 blue, 5 green, something like that. We get the world location, set it up inside the bounding box, and then we go ahead and spawn our actors within a random point within inside that bounding box. Now I went ahead and set a static value of 263 for the ground because when you set the Z value, sometimes they would spawn under the ground or up in the trees, despite the bounding box not covering those areas there. And then I said try to adjust location, don't spawn if it's still colliding. And we'll go back to that where if we want a specific number of total fuzzies that we set, it's going to go ahead and check to see is it a valid fuzzy that was spawned. If it was, go ahead and count the number of fuzzies of that color. So if it's a red, it's going to increment the red fuzzies. If it's blue, it's going to increment the blue fuzzies. And if it's green, it's going to increment the green fuzzies and store them back in an array of the fuzzy count by color. All right, let's go back to the event graph. All right. Ensure that a valid number, so we're going to look at the current number of fuzzies that have spawned. We're going to increment that and then compare it to the total number of fuzzies. If it is true, then all the fuzzies have been spawned and we'll go ahead and move on. If not, it'll go back and try and spawn another fuzzy. And this helps if we don't have, if it the set number is like 25 and did not spawn 25 because one's stuck in a tree, it won't spawn that one from the tree and it'll go ahead and re-attempt to do it because that'll turn out to be false. All the fuzzies spawn, and then we're going to double check just to make sure the spawn count is correct. So the fuzzy count, loop through the array, see how many we're supposed to have spawned. Here I have the types and how many of each type are supposed to spawn, append them, and kick them out on a string. And then finally, we're going to transfer this over to the character to store as a variable on him. A refactor, I would actually move this into the game mode, so it stores it in the game mode instead of in the character. But all it does is it's just transferring the fuzzy count from here to the fuzzy count on the player character. All right, so that was the fuzzy spawn system. Let's look at the player character. All right, so the movement components for the player character, the movement controls are actually inside C++. They're just the standard basic WSAD, arrow keys, and mouse looking around. That's it, no jump or anything like that. Okay, we're adding the interface to the player character. That way it can interact with the interface that's on the fuzzy character. Okay, do they implement it? If an object overlaps that does it implement, then it go ahead and executes the interact interface call. When the begin play begins, we also have a little delay. We get the fuzzy count after the spawn's finished making them. We're going to loop through it, and we're going to set our own variable inside here to the target fuzzies and how many of those fuzzies are existing within the game level. So if there's 5 red were created, it's not going to expect us to collect 6 red, or if we collect 4 red, wondering what's going on. So we'll have to collect. It knows how many reds were created, and it sets that value for us of that's how many reds we actually need to get. For the fuzzies themselves, we set up a behavior tree, very, very simple behavior tree. Goes down and then it goes to the sequence here from left to right. So it's going to find a random point using the behavior tree task. It's going to move to that point and it's going to wait 3 seconds plus or minus 1. That keeps the fuzzies moving around. Opening up the behavior tree. So when it's executed, we're going to cast the fuzzy pawn. We're going to get their current location. We're going to set a radius distance for them. In this case, I have it set to 1,000. And it's going to get a random point somewhere on the nav mesh. If it has a valid point on the nav mesh, it's going to set the blackboard vector of where they want to go. It's going to get the random location and it's going to set that as the key. And then it's going to have finished executing. That's it. Pretty simple on the behavior tree random location. All right, looking down. eFuzzy type. So this is the enum. It's basically just red, blue, and green. That's it. Structure. We're going to come through. We have the fuzzy type and the count, and this is so we can track when the fuzzies are spawned. For each of the color types, create how many or track how many was created of that particular color. Environment. I made the fence. blueprint tree. I also have a foliage tree. I didn't really spawn that one. I have the static mesh rock, and then I went ahead and added the static mesh rock to the foliage of the rocks. And then finally for materials, I have the M base color, a master material for base color, and a master material for fuzzies. Everything else is based upon material instances. And that essentially wraps up what this project has. If anybody ever has any questions, how to do the interface or interact interfaces, you can use that interact interface to pick up fuzzies, but you can also use it to open windows, open doors, open fences, pick up items, interact with NPCs and things like that. So if anybody ever has any questions about how to implement the interact interface, let me know. All right, that's it. Thanks.